The objective of this section is to introduce you to how engine maintenance affects energy conservation. Better engine control requires good measuring instruments. This includes a good fuel meter, handheld or bulkhead-mounted instruments to measure the combustion and injection pressure, calibrated exhaust temperature thermometers. The fuel meter is the key instrument in energy conservation. Usually, consumption is measured as grams per horsepower per hour. The diagram shows how it varies with the load. By comparing this with the optimal consumption, one can assess the engine's condition. However, this method is not good enough for a daily routine check, because the accuracy of the instrument is not any better than plus or minus 2%. A daily engine check is done by measuring fuel consumption, the exhaust temperature, the maximum combustion pressure, scavenging air pressure. If these readings do not vary by more than 1%, it can be assumed that the engine is running smoothly and there is no loss of energy. Comparison of the combustion pressure and the injection pressure is a very good aid in fault finding and adjustment. Looking at an injection and combustion pressure plot, an experienced chief engineer can at a glance see if the engine is running smoothly or not. The shape of the curves is a good telltale sign as to what may be the problem. Carbon buildup in the exhaust piping reduces the engine's performance. The scavenging air pressure is an indicator of carbon buildup. Indirectly, it also gives an indication of the turbocharger's condition. Any deposit on the exhaust piping will be registered by checking the temperature and steam production. Vibration checking instruments are useful for measuring the condition of any rotating machine, such as pumps, electrical generators, gears, compressors, or turbochargers. A vibration occurring at low speed indicates a shaft problem. At medium speed, it is often a damaged gear, and at high speed, bearing damage is a possibility. To detect unusual vibrations, one first has to register the average vibration of a new piece of equipment. This will serve as a reference for later measurements. An analysis of the lube oil helps determine its quality and may extend the interval between oil changes. Installing a lube oil separator also considerably increases the quality of the oil and the time interval between changes. By analysing particles found in the oil, one can assess excessive wear in the engine before a failure develops. The engine should be properly calibrated at least twice yearly. Much of its power loss can be traced to an improperly tuned ignition. For example, a delayed ignition increases fuel consumption by about 1.5% per degree of engine cycle. At reduced load and with poor quality fuel, advancing the time of ignition can be advantageous. For ships running on heavy oil, good fuel viscosity obtained by preheating is important. Adjustments have to be recalculated when changing the fuel quality. An increase in the scavenging air temperature increases fuel consumption. If, on the other hand, the temperature is too low, it will result in corrosion. Correct temperature adjustment is something between these two.